All right, so today we're gonna understand the GCF. So this is the first grade six lesson. So let's try to get started on the GCF. Let's try to get started on the GCF. All right, so we're gonna look at this word problem to identify the GCF. Emma is organizing her collection of stickers. She has two types of stickers: 48 stickers and 60 heart stickers. She wants to create goodie bags for her friends, making sure that each bag has the same number of star stickers and the same number of heart stickers when the stickers left over. So we're gonna have to identify the GCF of this problem. So first, it's gonna tell us she has 48 star stickers and 60 heart stickers. All right. Now we need to see how much same they're gonna be. So we're gonna have 48 on one side. They're gonna have 48 the other side. So now to find the GCF, first we'll have to list the factors to this. So what number multiplies to get to this product? I know the first number that does is 1 times 48, and the next one is equal to two times 24. So any number that multiplies to this number here is, since 2 times 24 that multiplies to here, and then we have 3 times 16. And then we also have 4 times 12. So here 4 times 12. We also have 6 times 8. So all the numbers here multiplies to 48. And same thing for the other side. Now since we know that all these numbers multiplies into 48, now we're going to find all the numbers that multiplies to 60. This case is 1 times 60 can work. Anything multiplied by 1 is equal to that number. So 1 times 60 is 60, right? It's basically that's what it is. So every time anything multiplied to that number is equal to that number. So now if it's even, it's divided by 2. So we can divide 2 times 32. Wait, let's see. Now 32 to 30. I'm sorry, it's late in the night right now. Next, we could do 3 times 20. That's equal to 60. And 4 times 15. That's equal to 60. And then we have 5 times 12. 6 times 10. I believe those are all the factors that multiply, right? Another you can find a GCF to do the prime factorization. But we're actually going to talk about that over here. But now let's just find it. So after you find all the numbers that multiply equals 60, now you're going to find the common factor. So what a common factor is basically the same number and both of the whole numbers. So here's 48 and 60. What are the same factors, right? I see one is a same. I will see one that is a common factor. So there's one. The common factor means that the number is on both whole numbers. So here we got one over here. Here, yep, 2. Then we got the number 2. We got 3. Here we also got 3. 4. Yep, on both of the numbers we have 4. So you can see so now the numbers are not all the numbers that appear the same. So one is over here, one is over there, one is over here, one is over there. So basically there's 6. But is there 8? No. So how about this side? Here we already identified that 12 is here. Is there any more numbers that we forgot? 48? No. 48, 24, no. 24. 15? Nope. 8? Nope. So those are all the common factors. So the common factors are 1, 2. You can't write them twice because it's the same number. You can't just put 1 and 1 two times. You know why? Because they're the same number, it means the same thing. So we could just put like all numbers that like matter. So let's say we put all the numbers over here that are written red. So we have 3, 4, 6, and 12. All right. So now what do we do now? So to now we're gonna find the GCF. So that's after you put the factors, after you find the common factors, our goal lesson is to find the biggest factor. So our number here is 12 because that's the biggest factor, right? It's the biggest factor. 12 is our GCF. So basically, we're asking us to basically the biggest number we can give our friends is 12. So that means it's 12. The GCF is 12. That's our GCF. GCF. So, my summary, what GCF means is the greatest common factor, right? It's the greatest common factor of two numbers, right? It's the greatest common factor between two numbers, right? As we saw over here, we saw that the common factor was the factor that is common in both numbers, right? The factors that are common in both numbers, all the numbers are in red. So it's 1, 2, 3, 4, 6, and 12. They're the factors, the common factors. We call it SCF. Now the GCF means the biggest common factor. That means what's the biggest common factor you found on both numbers? The biggest one is 12. You can put this in a fraction divided by 12, and you get the simplest form, which we're gonna talk about we'll talk about the next video using the GCF to simplify fractions. Now let's try another one. If we can find the GCF of 12 and 9 and 15. Well, remember the word GCF gives us a clue that we're finding the GCF. So the GCF means greatest common factor. To find the greatest common factor, find the common factor of both numbers. 9, 15. Now let's list what numbers multiply. So first, we already know that 1 times 9 is 9. And then it's not divided by 2. If you want to see how something's divided by 2, make sure the number is even, right? Since 9 is not even, it's not divided by 2. But let's see if it's divided by 3. It is divided by 3 because 3 times 3 is 9. We already know that. All right, that's it. No more. Because you can't put 0 because anything multiplied by 0 is equal to 0. So we can't put 0. How about here? We got 115 times 15. It cannot be divided by 2 because it's odd. So odd numbers can't be divided by 2. That's a rule we learned. So now it's also just 3 times 5. So 3 times 5. So now I'm going to list the common factors. So the common factors are the factors that appear the same in both numbers. So look, in this example, you have 3 and 3. What do we do if you have the same number? Don't circle both numbers. Just circle one of them. Because look, remember, they're the same number. So we're going to circle, but that's it. Oh, but you can never forget 1. So there's always be 1. A prime number is a number that can only be multiplied by 1 in itself. So these are not prime numbers because it can also be multiplied by 3 and 5, 3 and 3. But by example, 7 can only be multiplied by 1 itself. This means to multiply. Just another way, just a algebraic term meaning to multiply. So 7 is a way that we can say that this is prime because we can now list it because it's not divided by 2, not divided by 3, 4, or whatever. It can be divided by 7, which that gives us 1. So 7 is prime. A composite number is a number that when you multiply it, you can multiply more numbers, right? You can multiply 1 and 15, but also you can multiply 3 and 5. That's a composite number. All right, so now let's stop yip yapping about this. Now let's start using the common factors. Now the common factors are equal to 1 and 3. That's the only common factors. Now our greatest common factor is going to be the biggest factor in the numbers. So we already know that 3 is bigger than 1. So we're going to find the biggest factor. This is a true. This is true. This is true. Now it means our GCF has to equal 3. Or unless we're wrong. So this is going to equal 3. All right, let's find the G. Then now let's look at prime and composite numbers. Is 7 composite or is it prime? Well, we have to look what numbers multiply this. If it can only be multiplied by one in itself, it's prime. So this one is prime. So this one I can't write because I'm using my mouse pad. I'm really bad at writing. Prime. Right? But look, how about 16? That can be multiplied by 8 times 2. And 4 times 4. And 1 itself. 1 multiplied by itself. Now this has to be composite. So I put C because I'm not writing all that. Composite. Alright, good. Now let's move down here for our last problem. What's a GCF of 10 and 100? Alright, remember, first we're going to have to list the factors. So we're going to list the factors of 10 and 100. Oh, so that's a funky looking 0. Good. Now since we list the factors, we're going to find the greatest, we're going to find the factors. Not the greatest common factor yet, but just the factors. So here on the factors is equal 1 times 10. What else? Since it's even, it can be divided by 2. So if you divide it, you get 5. Just 5. That's it. No more numbers, they can multiply. We can't include decimals because the greatest common factor we can work a lot on whole numbers. So if we try to find whole numbers, it can only be multiplied by whole numbers. So this 100 can only be listed by factors that multiply that whole numbers, not decimals. So there's a lot of decimals that multiply to equal 10, right? But we can't do that. All right. I know that 1 times itself is equal to itself. So I know 100 is equal to 100. 2 times 50 equals 100. 4 times 25. Then after that, what else is there that multiplies to 100? I know a 10 times 10 can also equal 100. But what else? Let's think with our brains. Of course, we can think with your brains. Let's look. Can 7 be divisible? Can 8 multiply to get 100? Can 9? Can 6? Can 5? Yes, we have to think about it. 5 times 20. How about 4? We got 4, 3, 2. Alright, it's all the factors. Now we need to find the common factors. On the number here, the common factors are 2 and 1. Now we can find the common factors. So now we already found the common factors. Those are 2 and 1. Those are the common factors. Now how about the greatest common factor? Well, now I'm gonna have to find the number that divides most. GCF is 2. Why? Because 2 is greater than 1. This inequality is true. Inequality is just something that uses a greater, less than. We're just gonna talk about that later. But this inequality is true. All right, since we got a good understanding of GCF, let's see if you can find the GCF of 26 and 13. All right, let's see if you can find a GCF of 26 and it's an and I draw bad. I'm drawing on a mouse, not a mouse, not even a mouse, on a mouse pad. So it might be a little difficult to draw, but I'm gonna read it for you. The GCF of 26, 26, and 13. All right, now the GCF of 30 and say 45. All right, since we're good with this now, let's end this video and let's see if we can solve the problems. 30, GCF of 30 and 45, the GCF of 26 and 13. Good job.